Hello everyone and welcome to this webinar on dealing with vector data in GeoServer. This is a webinar that we are presenting as a company, Rotten Grapes Private Limited, and I'm really excited to host this webinar today. I hope people who are attending this webinar can learn something from it and apply it in their day-to-day activities. We will wait for a couple of minutes and then we will start the webinars. Meanwhile, if you have any sort of generic questions about GeoServer, please add them in the chat box and we will try to respond to them as much as possible. Thank you. Okay, so let's begin this webinar on dealing with vector data in GeoServer. Now that you're attending this webinar, I have assumed that you know what is GeoServer, and we will not be spending too much time into understanding the role of GeoServer and what can we achieve using GeoServer. In this particular webinar, we will be focusing more on how you can serve different types of vector data using GeoServer. So the table of content for this entire webinar would be installation, adding vector data in GeoServer, styling the data, and querying the data. There are multiple things that I have mentioned over here, and we will try to cover as many things as possible. Before we jump into the webinar, I would like to give a little bit introduction about the company. So there are plenty of fishes in the sea, why you can choose us. So we have been providing a service for more than 4 years now. We are Startup India recognized, and we are open source believers as well as contributors. Most of the developers that we have are actively contributing in various types of geospatial repositories such as GeoServer, MapLibre, and some of the OGC developer workshops as well. We have clients across all 6 continents, and we are definitely looking for the client in the 7th. We also provide support and trainings. So if you have a web application where you need help in supporting and making that application bug free or looking for maintenance, or if you have colleagues where you want to deliver some training related to open source GIS, you can definitely reach out to us. You can visit the website or reach out to us over email. So let's get started with installation of GeoServer. We are living in an amazing world where we have so many operating systems to choose with. So it's just like Linux, Windows, Mac, and we also have virtual OS now. So for example, Docker. GeoServer supports installation and on all of these platforms. First thing is we have to decide which server are we interested into. So do you want to go with Tomcat or do you want to go with Jetty? Tomcat generally is recommended way when you are putting your GeoServer in a production mode. This is very stable and quite lightweight. One of the main advantage is if you have other applications which will be also hosted on Tomcat, then this becomes an obvious choice because you can essentially use this for serving this data as well as other data sets. But if you are looking for development or if you want to try out some things with GeoServer, you can use Jetty as the base server. So this is essentially platform independent. So whenever you will go to the GeoServer's homepage, you will see that you will have multiple options. So you will have a platform independent option, and this is what the Jetty server means. There is no need of external servers such as Tomcat once we decide to go with the Jetty. It is very easy to spin up a new server using Jetty. So before we move forward, let's have a quick look at the GeoServer homepage. So from here, you can see that they have three core repositories available at this point of time. One is stable, one is maintenance, and one is under development. So if you click on the stable version, you will see platform independent binary. You will also see Windows installer, web archive, and the data directory with the sample layers in it. So platform independent binary is the Jetty server, while web archive or WAR is your Tomcat based server. So depending upon what is your need, you can pick what you want. We do have blogs and videos published about how to install this GeoServer on different OS such as Windows or Ubuntu or Mac, or even if you want to get started with the Docker. So you can simply go through the blogs and videos and understand how this installation can be done. I'm just going to read through the chats. If there are any questions, I will reply to them. Can we do a CRUD with GeoServer using only APIs? It is easy to use GeoServer APIs to read. There is a question by Thomas that can we do a CRUD using GeoServer APIs with only APIs? So essentially it is possible. There are GeoServer REST APIs which can help you. But if you want to update the data, or if you want to add the data, or if you want to delete the data, you don't actually need to use GeoServer via API, but you can use a WFS transaction call. This is an amazing I would say this is an amazing implementation by GeoServer, where it allows us to update our feature or to update our uh, data. It can be a metadata or it can be a geometry, to add new data or to delete the existing feature directly from GeoServer itself. So it doesn't matter if your feature is coming from a shapefile or from a PostGIS or anything else. Using GeoServer, you can control that data and then change that data set itself using WFS transaction. So you can search for GeoServer WFS transaction to know more about it. There is one more question that, and this is a very interesting question, and this is something that I hear a lot, that users will host their GeoServer on some cloud platform, and then they will try to add the data as a shapefile using their own machine. So essentially it is not possible. The reason behind this is all these workspaces, all these stores that we have on GeoServer are actually stored in a directory known as data directory, which lives inside your GeoServer folder itself. Ideally it lives inside it, but it can be outside as well. But the idea is that there is a folder which contains all the configurations, and that folder essentially is used to understand what all workspaces or stores or layers that you will have in your GeoServer. So if you have hosted your GeoServer on some cloud platform, and if you are trying to connect it with the local shapefile, it will not work. Either you will have to put that shapefile in some hosted database, or you will have to put that shapefile in the your cloud instance itself, where it can talk locally with the GeoServer and host the data. So I hope I was able to answer a few of the questions. Now once the installation is done, this is the main part. So we want to understand how and what all different vector datas we can serve using GeoServer. Before getting into that, I would like to shed some light on GeoServer structure. So how exactly GeoServer is structured? So essentially, once the GeoServer is installed, you will see a nomenclature known as workspace. So you can think about workspace as a project itself. So if you have a GeoServer and if you're dealing with multiple projects at a time, you can create a workspace for each project. So workspace can be also considered as a folder. Then you have a store. So store is essentially a connection of your GeoServer workspace with some sort of physical data. So it can be a data as a shape file, or it can be a TIFF file, or it can be a connection with the database. So store essentially stores the information about the configuration to connect this data set with your workspace. Now store can either serve a single layer or it can serve multiple layers, and that is why, as you can see, for example, store number 3 is actually serving two layers, layer number 3 and layer number 4. And similarly, I forgot to mention this, that workspace will contain multiple stores, but each store will be only connected to one workspace. So one workspace can have multiple stores, but one store will be only a part of one workspace. Similarly, one store can have one or many layers. It will depend upon what type of store it is. And finally, our journey ends here. Once we create the layer, we are ready to serve this data using uh, different formats available. So WMTS, which stands for Web Map Tiling Service, then WMS, Web Mapping Service, WFS, Web Feature Service, WCS, Web Catalog Service, and GWC, which is Geo Web Cache. So we have multiple outputs available for the layers that we have hosted. And this is one of the key reason why we promote to use GeoServer. Is once you have the setup done, it doesn't matter what is your store or what is your input, you can actually standardize your output of the data and then use it in your client side, such as open layers or leaflet or anything else that you want. There is one more question, that can we add a big size file like TIFF files, and can others download it even if they don't have GeoServer? So to answer the first part of your question, we can definitely add big size TIFF file into GeoServer. But the real question is, how do you optimize it? This is one of the key things that we try to solve at our company. Is we have clients who has big data, but they want to share this data, and at the same time they want this data to be lightning fast. And obviously there are limitations for hardwares as well. We cannot have a hardware with infinite RAM and infinite storage. That is where optimization comes into the picture. This is one of the key things that we try to do at our company, is how we can optimize the data that you want to present on the front end. So sometimes we do optimization by filtering the data, sometimes we do by styling it in a way. And in terms of raster data particularly, there are multiple ways we can do it. For example, we can convert it into smaller rasters and then serve the rasters, and there are many more. We will try to cover it in depth in another webinar, which will be dedicated to raster data. There is another question for explanation of WMTS, WMS, WFS, and other data formats. So WMTS is a web map tile service, which means you can serve your data as a tiles, while WMS is your mapping service, which means essentially you can also serve this data as a tile, but this tile will be in the format of either PNG or JPEG or anything like that. And generally these are the ways that we use, where we want to uh, host our data and share our data in an image format. While WFS actually consists the GeoJSON or a vector format essentially, which consists of all the data uh, in a feature wise format. That means it will have geometry and it will have all the properties in it. Then we have a catalog service. So catalog service essentially is used to create a catalog of all the data set available inside your GeoServer. So if you have a GeoServer installed, and if you can simply go to your GeoServer homepage, you will see this service capabilities document. So these are essentially your catalog service document, and there are multiple WCS requests available. For example, get capabilities is one of the requests. So essentially this will have entire information for your GeoServer in a get capabilities format. Uh, all right, so I think we have talked enough about the structure of GeoServer, and now it's time to get our hands dirty and try to understand what all different vector dataset we can deal with. There's also a question on the chat which talks about how much does it cost on a monthly or yearly basis. I'm not clear, Onkar, if you want to explain your question, maybe I can definitely help you. There's another question that I have a GeoServer login credentials. I think we have already covered that one. So yeah, there's another one, that do we have any maintain GeoServer like PGSQL maintain version? There are companies who provide this service where they will maintain GeoServer. Fortunately, we are one of those. So if you go to rottengrapes.tech/geoserver, the link available in the on your screen in the ticker and also in the description, you will see that we also maintain GeoServer for quite a few companies across the globe. So that means essentially it is our duty to back up their data. to make sure that securities are up to date and the data is optimized whenever it is needed. So now again, let's get back to the main presentation and try to understand what all different vector data sets that we have that we can deal with. The first one that I have written is external WFS source. This is how you can connect an external uh, get capabilities document into your GeoServer. So it doesn't matter if your data is coming from just GeoServer or any other get capabilities provider software. But essentially, once you have that URL, you can utilize that data into your own GeoServer. Now let's take an example of this. Under my stores, I have this web feature service for one of the projects that we worked with, where I have provided a get capabilities document similar to the document that we have seen earlier. This is a similar type of document where I have provided the authentication for this as well. Now if I go to the layers tab and if I try to use that store to see what all layers available inside it, you will see that we have tons of layers available. So these layers are essentially hosted on another GeoServer instance, which also gets this data from another PostGIS instance, and then it will come from that PostGIS to the GeoServer, and from that GeoServer to our local GeoServer. And once the data is here, we can host this data. For example, I have this building data set, so I can simply host this data. And we have this data. So this is the first format that we want to discuss with, is an external WFS source. Here the key thing is you might need the authentication username and password, but it will depend upon how the configuration of your external service is done. Once your external once you have connected that service, then you can essentially access all the layers that are available and which are advertised in your original source. Next thing we have is a shapefile or a folder directory. So this is a very common use case where you have your own data and you want to host that data. So if you have a data such as shapefile or directory of shapefiles or a geo package, you can use these stores to connect that folder with your GeoServer. Now again, this is how exactly we will do it. Even though if you are hosting your GeoServer on some cloud platform, you will then need to take your shapefiles or geo package on that cloud platform and then make that connection. So if I go back to my GeoServer one more time, here if I click on dataset, data source, and if I go to shapefile, you might not see these many options available. This is because I have few plugins installed. We will talk about them later. So once I go to shapefile, you will see that I can browse and look at the data directory, and obviously this will only show me the data directory of my computer itself. That means this physical computer on which I am taking this webinar. And this is exactly why you are not able to find your local shapefile on your cloud instance. So once you have given the path, you can save this store and you will have store very similar to this. So here you can see that I have this data folder and /nyc. Now some of you might have this uh, doubt that why do I have file, because in some of your use cases you might see something like C colon and then the file path, or D colon and then the file path. The reason why I am only specifying file and then dot is because this nyc folder actually lives inside the data directory folder. This is very important because data directory, as I mentioned earlier, is the folder in which all the configurations are stored, which are essentially executed or read through when we start our GeoServer instance. But if I have some data which is in my downloads folder, I can actually look for that folder. So for example, if I go to the home directory and downloads, there might be, yeah, so there are a few shapefiles available. So I can actually click on those and now you will see that I get the complete path. So this is /users /krishna glodha /downloads. This is because the file now is not inside the data directory, but it is outside the data directory. And this is why I have to give the complete path, right? And now if I go to layers, you will see the 3D vegetation layer available. And just like that, I can host this data. Okay, similar to this, you can also make connection with the geo package or with the folder in which all the shapefile lives. So if I have to give you an example, let's take the similar example of the same folder that we were dealing with. So folder shp. Here, instead of specifying a single shapefile, I will be specifying the folders inside which I want GeoServer to look for all the shapefiles available. So the end goal over here would be to give the path of the folder. And once I click on save, you will see all the layers or all the shapefiles available in that folder are visible. So I can select any layer that I want to publish and then I can publish. So if I add a new layer or new shapefile in that folder, that will be visible in this store configuration, and then I can add that layer on my GeoServer. Next is MySQL connection. MySQL connection is a little bit tricky because the connection itself is not supported by default by GeoServer. So you'll have to install an external plugin for that. So I recommend to go to this URL. I'm also putting the URL in the chat box. And once you are at this URL, you can look for the version of GeoServer that you are using, and you can find the list of all plugins available. Here under ext, I might find the plugin of MySQL. So there is a plugin for MySQL. So I can simply download this. Once it is downloaded, I can copy the jar file in it, and now I will go to um, I'll now go to the folder of my GeoServer. So sorry for this. I'll simply go to a new folder, which is my GeoServer directory, and inside this I will go to web apps, GeoServer, webinif, lib, and inside this I will paste these jar files. Now I have already placed this. Now always remember, whenever you will make changes to the configuration of GeoServer, you will have to restart your GeoServer, because as I explained earlier as well, GeoServer, one of the reason why GeoServer takes a little bit more time to start is because it reads all the configuration in the beginning itself. So that is why whenever you will make change to your GeoServer, you should open your terminal, and here you should restart your GeoServer. So I'll simply stop it and restart it one more time. And once it's restarted, you will see your plugin, whatever plugin that you have installed, is available in GeoServer. Now coming back to the MySQL connection, this is a straightforward process. Let me check if my GeoServer is up and running or not. There is the question that which cloud platform will you suggest? So essentially, all cloud platforms will work. As I explained earlier, it doesn't matter if you're on Windows machine or Ubuntu or Mac. Any OS will work, and cloud platform can be anything like AWS or GCP, Azure. Luckily, we also provide servers. So if you need servers at a cheaper cost, you can check out rottengrips.tech/server for this. There's another question that can it be used for power utility and integration with the live data? This is definitely possible, and we will now see how exactly this is possible. I believe my GeoServer is now up and running, and I can go back to my GeoServer, click on new store, and now you will see MySQL and MySQL GNDI, both options available. Now you can simply click on MySQL and select the name of the source that you want to give. It can be anything, and then you can simply specify the port, the user, the password, and the host. In my particular case, I have started an MySQL server using Docker. So I have this MySQL image of Docker going on, and I have added some data into it by default. Adding data into MySQL can be a little bit tricky because, for example, as you can see over here, I have uh, two tables with the name airports, but in one of them the geometry is a text format while other one has the geometry format, and this is the only one which will actually work. So if we go back to our GeoServer and try to connect with this MySQL, you will see how exactly this will work. So if I go to URL and if I search for MySQL for layer, you will see that if I try to host that another layer, you will see that both of these are string format, and because of this our SRS is not correct, and because of that we are not able to get the native bounding box correctly and the data will not be presented. So you have to be very careful whenever you are using database like MySQL to be sure that your layer or your table has the geometry column available inside it, otherwise it will be very tricky. Okay, great. So this data, for example, we have this airports layer which is coming from MySQL itself. So this data we are serving from MySQL. Now the next one we have, which is most common way how people use a database and GeoServer, is a PostGIS connection. And because this is the very common way, GeoServer already supports PostGIS right out of the bat. So you don't need to install any another plugin to use PostGIS. But the way you can use PostGIS is very similar to how you can use MySQL. You can simply go to the stores, you can search for PostGIS and make connection with the host, port, schema, database, username and password. Now, for such types of databases, it GeoServer doesn't only support the tables that you have added, but also supports other things such as views and pre-generalized views. For example, if I open my pgadmin, you will see that under the Postgres database, I have few tables and also I have few views available. Right. So here you can see that we also have a view where we only have this the name or the code of that country and the geometry itself. So if I host this view, then I will only see this data. And if I host the entire layer, obviously I will see all the columns available in it. So if I open the column list, you will see that there are more than 170 columns available inside it. So it will be easier for me to create a view and then host this. But what if you don't have a liberty to do that? What if the database that you are connecting with is hosted somewhere else and you as a user doesn't have access to that database? In that connection, or in that situation, sorry, you can actually create this SQL view on your own. So if you go to the layers and if you click on that PostGIS connection that you have made with the data store, you will see this option of configuring new SQL view. In this particular view, we can also we can essentially send the information as a SQL statement. So I can do something like select star from, or maybe I don't want to do star, but I want to do ADM 0 underscore A3 and geom from countries. So just like this, and if I we already have a we already have a view created, so I'll simply show you that view. I believe it is under the name of, sorry, we already have a layer available. And we also have more information about it over here. So for example, as you can see over here, we have created this view with select and then few column names from countries, and we have also given a where clause where we are essentially asking this information to be a variable. That means when we will call to the WMS layer, we can pass this information from front end and only get that particular data from database. So imagine like you can write your own SQL views, and instead of serving that data directly from Postgres to your front end, you can actually put middleware like GeoServer, which will help to maintain this, help to style this and get this data set. So If I go to single country layer, I believe this is the one. So once we have hosted this layer, you can see that we can simply pass the information like a view param. Because we have added n as a variable over here, we can pass this n variable in the view param and get only that particular data set. So I hope this is clear to you guys. If you have any questions, please drop them in the chat box and we will try to cover them. So Postgres SQL view allows you to create the SQL query inside GeoServer itself. So this can be helpful for you when you don't have access to the database, or you cannot make any changes to the database, or like add a new view and things like that. Just like you can create an SQL view in the GeoServer, if you have a pre-generalized view in your Postgres connection itself, you can also use that data, or you can also use that particular connection to create a layer on GeoServer. So I hope this is clear to you guys. Now, we are also living in a world where NoSQL databases are now starting to rule the world. Now, big organizations are getting serious about using NoSQL databases for different use cases. In geospatial domain as well, we have significant use of NoSQL databases such as MongoDB. Now, MongoDB is not something that is supported by default in GeoServer. So again, similar to how we downloaded the plugin for MySQL, we can download a plugin for MongoDB. So again, we will go back to our build.geoserver.org, and here we will look for a MongoDB plugin. Now this MongoDB can be hosted or it can be your local MongoDB. So in my case, I again have a container for MongoDB. So if I go to localhost 8081, you will see that I have this Mongo Express, inside which I have this database known as Geos, and it has a collection known as port. So essentially it stores all the information about port. Again, to store a geospatial data on a MongoDB, there is a specific format that you have to follow, which means you have to give geometry column as a GeoJSON point or line or polygon or any sort of geometry information. So you have to follow the GeoJSON format in order to send the geometrical data, so that MongoDB can understand and save it as a geometry rather than saving it as like a string data or a float data or something like that. So I have this MongoDB setup done, and I have also added some data into it before the webinar so that we can see this data. Now to connect MongoDB can be a little bit tricky. I myself spent quite a few hours to get this MongoDB connection right when we had first client who was using MongoDB actually. So in this particular thing, you will see that I have already created a store for you. So if you are using MongoDB, one thing that you will see that if you refer to the documentation available from GeoServer, they will only recommend you to add something like MongoDB and then the localhost and then your database name. But unfortunately, you will have to change that URL. So if I open a, so this is how my URL looks like. And if you go to the MongoDB's documentation by GeoServer, you will see that the URL that they present is very straightforward, where it is simply localhost and then the port number. So it is simply like this, localhost and the database, that's it. If you try to send it like this, you'll definitely face an error, and that is why I recommend to add the username, the password, at the rate the port, the at the rate host colon port slash the database name slash sorry, question mark auth source is equal to admin. So this is how you have to configure your MongoDB URI. Once the URI is configured, second thing is schema store. So essentially, as we know that MySQL, NoSQL databases are generally schemaless. That means you can pass any type of data uh, in the same database. But in order for GeoServer to utilize this data, GeoServer has to set up its own schema for that MongoDB connection. So we have to give a folder path inside which GeoServer can create that schema. We don't have to create that schema. Please remember that we don't have to work on any of schema creation process. GeoServer will automatically figure out schema based on the database that you're trying to connect. And it's just that we have to give the path where exactly MongoDB should store that schema, right? And once that is done, there is one more thing that we need to do on MongoDB side, which is allowing the index. So there is this index thing that is there in the MongoDB, and generally you can check out the documentation for this. So we have to pass an index where we can specify that this particular column, the geometry column, is of a type of 2D sphere. Once we add it as a 2D sphere, it will actually consider it as a geometry. I already have a blog available about this on medium.com. I will send the link in the email afterwards, where you can actually understand and you can copy the data from there. So these are all connections that we can make with GeoServer directly. There are various other ways available as well. So there are things such as Elasticsearch, MS SQL, Oracle database. All these connections you can also make with GeoServer, and depending upon your use case, there are documentation available from GeoServer itself which can help you to do that. Now let's talk about styling data. So as I mentioned earlier as well, styling itself can be a part of their entire webinar. So we'll just try to touch base and understand the basics of styling in this webinar, and laterwards we will have a dedicated webinar for styling itself. So there are four styling uh, extensions that are available. SLD is the default one. Then you have YSLD, then you have a CSS and MB style. Now depending upon the way you want to write code, you can choose the language that you are interested in. But what if you are not a programmer? What if you don't want to code? In that case, we have a solid option of GeoStyler. GeoStyler is an amazing way how you can create styles without writing a single line of code. You can simply load your data and try to create style using the UI available by GeoStyler. If you don't want to also use GeoStyler, you can use softwares like QGIS, inside which you can create your style and export it as a SLD and then import it back in GeoServer. So this gives us enough flexibility to work with the softwares that we want or the language that we want and create the styling available. There are various types of styling options available. A simple style can be based on the color or the border of the features or the graphics that we want to implement in that feature, etc. Then there are style dependent on the scale. So this becomes helpful when you're trying to load or show big data. So I want you guys to do something for me. If you go to Google Maps and or any other maps such as OSM, if you try to look at it from a bigger level, so by bigger level I mean if you try to zoom your map out so that you are seeing the India, in that particular case you will not see a very detailed map. But as you start zooming in, you will see more and more features becoming available on map and more details start popping up. This is because they are set using scale dependencies, and only after certain scale those features will be visible. So this becomes really handy when you want to create applications where you need to create your own base maps. Then there are style based on attributes. You can use attributes available or the metadata available in your store or in your layer to create style. So something like if you have a column known as sold where the value is true or false, you can actually color code your data according to this true or false value. You can also use and, or, and not operators to connect multiple conditions together. So you can have something like area of house is, or let's say the address of house is in XYZ region and sold is equal to false. In this case, it will only give you the results where the both of the conditions are matched perfectly. Just like how we have used attribute based query, we can also use geospatial queries. So this can be filters that you can apply. And finally, we have style based on variable substitutions. This is an amazing way how you can create styles where you define, just like if you remember our SQL view, we define a variable over there and then we ask for the value in our client, and then according to what our client will select, that particular value will be sent back. There are few blogs available from our side which you can refer to if you are trying to understand how to style lines or polygons or labels or point. Then we have filtering of data. Again, we will have a separate webinar for this available later. But in this one, I want to focus on what all different what all different filtering types we have. So first one is attribute based filtering. That means based on the metadata or based on the column. So for example, in this particular use case, we have the data for all the countries available in the world, and we are trying to attribute query it based on this column known as admin 0 underscore A3, and we are trying to see what feature has the value of IND for that particular column. Just like that, we can also get all the data based on the list. So we want all the features where the name is either IND or PAK or CHN. So this is essentially finding out all the features which are part of that list. Then we have a bounding box based filtering, which means we pass a bounding box, and we will, in this case, we don't deal with the attributes, but we deal with the geometry of that feature itself. So essentially we pass a bounding box and we return all the features available inside that bounding box. Then you have geometry based filtering. So geometry based filtering can use uh, any type of geometrical data based on the geometrical interaction. So for example, you can have contains, or you can have within, or you can have intersect. So all these type of different geometrical filterings you can do with the WKT of the polygon or the point or the line or any feature that you have and the geometry available in the layer. Then we also have a comparison based filtering. So instead of trying to work with only string data, we can also work with the numerical data where we can get information based on this float value or this numerical value. So here we are looking for the places where the population estimation is greater than 100 million. So just like this, we can also add multiple filters together. As I explained earlier, we can have and, or, not, and we can see these different types of things. So this is one of the example where we are trying to see the population estimate is greater than 100 million and the name of the country should be in the list of IND and USA. So these are different types of filterings that we have, and again we will have a separate webinar on this where we will actually see and we will actually create our own filterings and we will see how to use them in the real life scenario. Now before we go ahead, I would like to introduce Geoserver as a service. So this is one of the products that we serve where we are trying to essentially focus on following problem. So if you are facing the problems of maintaining your GeoServer, it can be challenging because you have to read and understand the logs in order to understand why exactly your GeoServer is failing or where exactly it is failing. Or maybe if you need help in optimizing the style for better and quick visualization. Or in some cases, if your data is too much and if you want to create a cluster of GeoServer so that it can have uh, a maximum availability, we can actually create a cluster for you. Then there are custom requirements for securing your data. So this can be using auth 0 or any other OAuth or Realm integration or OAuth integration or JWT based integration, or it can be a simple integration of the security. and managing and updating your GeoServer and your plugins. So these are the services that we are providing. There will be upcoming webinars which will be about security of data, styling of data, REST APIs, and raster management. So this is all that we have in this particular webinar. Thank you all for attending. If you guys have any question, I'm available I'm available to look at them in the chat, and then we can definitely try to answer the questions. There's this question about the correct map of Bharat, and I completely understand this, but for this particular thing, I wanted to use the data available with the website Natural Earth Data, because it is very important for us to use the data whenever we are doing any sort of public webinars or something like this. The data should be available for open source use, and Natural Earth Data is something that we can use for our commercial as well as for any other use uh, for free of cost. And this is exactly why we have used Natural Earth Data for this particular webinar. There's this question that if I want to build a web application using open source, what will be the process? What should I use? Could you suggest few application names? This will actually depend upon the use case that you have. For front end, as I said, you can use something like OpenLayers or Leaflet or MapLibre if you want to go with open source. For backend, you can use database like PostGIS. You can write APIs using various languages available. For example, you can use PHP or Java or Python or even JavaScript to create your own APIs. So essentially, it will depend upon what is the use case, and based on that, you can select the stack. Yeah, there are a few comments about the official borders. So we'll definitely look into it, and we'll make sure that for our next webinar, the same mistake will not be repeated. Again, I apologize. It's obviously, as an Indian, I would want to show the correct state boundary, and I'll take care of it. Thank you, guys. There's again a question of how exactly we can do the configuration of realm authentication. We can definitely have another, we can definitely cover this in another webinar where we talk about the security. There's a question by Thomas that if there are any basic web mapping related projects that are available that you can share. Essentially, we had two full web mapping projects that we created earlier. So if you can just go to the channel, you will see that we created an app for your COVID related web mapping. And there was this another web application that also we created. So I hope you can find the videos, and I hope those videos will be helpful for you. Thank you. Okay, thank you everyone for attending, and after this you will receive an email regarding the same the webinar. I hope you guys will go through the email and let us know your feedback. Thank you everyone.